Mechanical energy. You need this paper and 3 colors, specifically yellow, green, and blue, or yellow, red, and orange. Okay? Here's the worksheet. Before we do the worksheet part, we're going to just do a few little quick notes in the journal. First, we're going to start with a definition. So we want to define mechanical energy. Mechanical energy is the total energy in a system. Now, a system is anything we can isolate the movement of a single object without any outside forces acting on it. Easy way to think about this is we're just going to pretend there is no friction. If you can pretend there's no friction and you have an object where no extra force is being added, we pretty much have a system. All right, now keep the comments here nice and small because we want to be able to fit this paper in later. So, formula, skip one line. Formula, ME equals PE plus KE. Well, from the previous journal entry, we know PE is potential energy. And we know that KE is kinetic energy. So that leaves us with ME is mechanical energy. Now, units of measure. Units of measure for potential energy are joules. Units of measure for kinetic energy is also joules. So the units, when you add potential energy to kinetic energy, joules added to joules, our units for mechanical energy are also joules. Okay? So that's just a brief, quick introduction to mechanical energy. Now let's go to the worksheet and discover what it means when we talk about mechanical energy. All right. We have here a diagram of a skier. Now, our skier here, on the diagram, information is provided about the skier. And we have the skier at different positions. Positions A, B, C, D, and E. And we have down here a data table. We're going to take the data up here and apply it down here and discuss it as we do that. So, at position A, we have a kinetic energy of 0 joules. So position A, kinetic energy, 0 joules. At position A, the potential energy is 50,000 joules. So position A, potential energy, 50,000 joules. Next, position B, kinetic energy, 20,000 joules. So position B, kinetic energy, 20,000 joules. Position B, potential energy, is 30,000 joules. Similarly at position C. Now notice, as he's going down, that potential energy went from 50 to 30 down to 15. Height is decreasing, potential energy is decreasing. So at position C, that potential energy is only 15,000. Whereas in position A, it was 50,000, then to 30,000, then to 15,000. It's going down, down, down. At position C, the kinetic energy, however, is 35,000. If you watch the kinetic energy from positions A through B, it's 0, 20, 35. It's getting greater and greater and greater. As the skier goes down the slope, he's going faster and faster and faster. Okay? Position D, the skier goes flying up into the air. We have a kinetic energy of 20,000 joules and a potential energy of 30,000 joules. Now those numbers probably look familiar because they're the same numbers, position B and position D. Kinetic energy of 20,000 joules, potential energy of 30,000 joules. Well, what does that mean? Well, that little dotted line there is a first hint. if the potential energy, it's the same person in the same system, 30,000 and 30,000 potential energy, this tells us that positions B and D are the same height. The fact that those numbers are the same. Now, the kinetic energy is both 20,000. The fact that they have the same kinetic energy tells us that we're talking about the same speed. Equally fast. At this point down the slope and at this point up in the air, going at equal speeds. Okay? Now, down here at the very last point, kinetic energy of 50,000. And potential energy of 0. Well, why is the potential energy 0? Well, if you look at it, the heights, that's 100, that's 30, that height is 0. So that is why the potential energy is 0. But if you look at the kinetic energy, 50,000, look at all those values for kinetic energy, 0, 20, 35, 20, 50. That's the biggest number for the kinetic energy. When that skier is right there at the very bottom, that skier is going its fastest. Maximum speed right there at the bottom because it's maximum kinetic energy. So now we've analyzed the kinetic and potential energy of that skier at different positions. Those values change because as those values change, the height and the velocity of the skier changes. But let's look at mechanical energy. Mechanical energy is the kinetic plus the potential energy. So 0 plus 50 at position A, the mechanical energy is 50,000 joules. At position B, the kinetic energy of 20,000, a potential energy of 30,000, the mechanical energy is going to be 20 plus 30, 50,000. At position C, we have a kinetic energy of 35,000, a potential energy of 15,000 to give us a total mechanical energy of 50,000. And then at position D, the 20,000 plus the 30,000 gives us 50,000. Interesting. And at the end, 50 plus 0, 50,000 again. Very important observation there. Notice that total amount of energy does not change. Mechanical energy is a way for us to calculate the law of conservation of energy. Energy is not created nor destroyed, it just transforms. So it's transforming from potential energy to kinetic energy, and then kinetic energy back to potential, and then potential back to kinetic back to potential, back and forth. That energy transformation back and forth, but the total energy doesn't change. It's just changing what type of energy it is. To better understand this concept, we are going to graph it. Your three colors. We're going to start with yellow. Yellow is going to be our potential energy. Our potential energy is going to be yellow. At position A, the potential energy, PE, is 50,000. So starting at the bottom, each one of those bars represents 10,000. So 10,000, 20,000, 30,000, 40,000, 50,000. 50,000 joules of potential energy. At position B, our potential energy is 30,000. So starting from the bottom, 10,000, 20,000, 30,000 joules of potential energy. At position C, potential energy is 15,000. So that's just one bar and half of the next one for our potential energy at position C. At position D, potential energy is 30,000. So 10, 20, 30. And at position E, our potential energy is 0. So I'm going to leave it blank. Now, get your blue. If you have orange and red, grab your red. So blue or red. We're now going to do kinetic energy in blue. At position A, our kinetic energy is 0, so I'm not going to color any blue in. At position B, our kinetic energy is 20,000. Now watch carefully. I'm going to start from the top and go down. So 10,000, 20,000. At position C, 35,000. Starting from the top, 10,000, 20,000, 30,000, and half of the next block. Okay? At position D, 20,000, starting from the top. So the two blocks from the top. And at position E, 50,000. So I've got 1, 2, 3, 4, 5. All 5 boxes of kinetic energy. Now, let's do mechanical energy. Mechanical energy happens when we take the kinetic energy, we add the potential, we get the mechanical. So, 0 kinetic plus 50 potential gives us 50 mechanical. Position B, 20 kinetic plus 30 potential gives us 50 mechanical. Position C, 35,000 of kinetic energy, 15,000 of potential energy gives us a total of 50,000 mechanical energy. At position D, we have 20,000 kinetic, 30,000 potential. Add them together, we get 50,000 of mechanical. And at position E, 50,000 kinetic, 0 potential gives us 50,000 of mechanical. The mechanical total amount of energy doesn't change. Here, the potential energy decreased, but the kinetic energy increased. The total still remains at 50,000. Here, the kinetic energy continued to increase, the potential energy continued to decrease. Total is still 50,000. Now the kinetic energy decreased, the potential energy increased, and the total is 50,000. And here we have absolutely no potential energy. It's all kinetic, but the total is still 50,000. So yellow and blue make green. Yellow and blue make green. So when you add the kinetic and potential together, you get mechanical. That's what the graphic is for, to help you visualize that. That doesn't matter what the kinetic and potential are, the mechanical is an addition of those two values. Always stays the same. Let's look at a fresh new example. Okay? We have a roller coaster. We are going to record the data provided in the diagram for the roller coaster. So at position A, we have a kinetic energy of 0 joules. Now wait a second, 0 joules. Kinetic energy is the energy of movement. If I have 0 joules of kinetic energy, tell me about the movement of my object. Well, it's at rest. It's not moving. All right, potential energy, 40,000 joules. That's a nice big number. Notice it's really high up. All right, position B, that point right there. Data provided, kinetic energy, unknown, but the potential energy is 20,000. At position C, the kinetic energy is 25,000 joules, but the potential energy is unknown. At position D, the potential energy is 7,500 joules, but the kinetic energy is unknown. At position E, the potential energy is 0 joules, the kinetic energy unknown. At position F, potential energy is unknown, but the kinetic energy is 35,000. And at position G, the kinetic energy is 40,000 joules, but the potential energy is unknown. All right, given that information, take a moment. Mechanical energy is the kinetic plus the potential. Well, the only place where I have both pieces of data is at A. 0 kinetic, 40,000 potential. What's my mechanical energy? 40,000 joules. Now, what did we learn from the skier about mechanical energy? We learned that the mechanical energy is constant. The mechanical energy does not change. Position A, position B, C, D, or E, it does not matter the position within the system, that mechanical energy is constant. It does not change. It stays the same. So in this system, if my mechanical energy at position A is 40,000, my mechanical energy at position B is 40,000. My mechanical energy at position C, even though we have less potential energy, we're going to have more kinetic energy, the total is still going to be 40,000 joules. My mechanical energy at position D is going to be 40,000 joules because it's going to be 40,000 joules at every position, including E and F. Because that is a constant value, the total amount of energy does not change in that system. It remains constant. So, position B. If I know the mechanical energy is 40,000 and I know the potential energy is 20,000, how much kinetic energy does it have? Well, kinetic energy plus potential energy equals the mechanical, so you just take the mechanical minus potential to get the kinetic. We get 20,000 joules. At position C, if I have 25,000 joules of kinetic and 40,000 of mechanical, I'm going to subtract those and I'm going to get 15,000 joules of potential energy. If you notice, A, B, and C, they get lower and lower and lower. Potential energy, 40, 20, 15. Position D, even lower. Potential energy is only 7,500. So my mechanical energy stays the same. My kinetic energy 32,500 joules. Add those together, you get 40,000. E, potential is 0. That means my kinetic is 40,000 joules. At position F, my kinetic is 35,000. That's a pretty big number. That means I only have 5,000 joules of potential energy. At position G, I have 40,000 joules of kinetic energy. I've got 0 joules of potential. So that is how this works. If you know 2, you can find the third one. So our kinetic energy of movement, the lower the potential energy, that's the energy because of its height, the lower the potential, the greater the kinetic. The lower the kinetic, the greater the potential. The ball starts at rest. So now we have a new scenario. Look at it just one more way. We have a ball that starts at rest and released from the high point to the left. So if it starts at rest, what does that tell us about position A? At rest. If it starts at rest, our velocity is equal to 0. Now we look at our diagram. We know that the mass of the ball is 2 kilograms. At position A, it has a height of 4 meters. At position B, we have a height of 2 meters. C is a height of 1 meters. Position D is a height of 0 meters. E is 2 meters, and F, height of 4 meters. We are given information about the mass and the height of the ball at different positions. So, knowing mass and knowing height, what can we calculate about the energy of the ball at position A? We can calculate its potential energy. Potential energy is mass times gravity times height. Now, for the sake of these notes in this worksheet, we're going to round this value for gravity to 10. It's normally 9.8, but to make the math easier and faster, to see the patterns, we're going to round it to 10. So the potential energy at position A is the mass, 2 kilograms, multiplied by gravity of 10, multiplied by a height of 4 meters. 2 times 10 is 20. 20 times 4 is 80 joules. So I have 80 joules of potential energy at position A. Position B. I can again calculate the potential energy because I know the mass, I know the height, and I know gravity. The mass is still 2 kilograms. The height now is, gravity is still 10 meters, 10 meters per second squared, and the height now is only 2 meters. So 20 times 10, 2 times 10 is 20, 20 times 2 is 40. 40 joules of potential energy at position C. B. At position C now, potential energy, mass of 2 kilograms, multiplied by gravity of 10, multiplied by a height of only 1 meter. 2 times 10 is 20, times 1 is still 20. 20 joules. All right, we're doing great on that potential energy. We just keep plugging that formula and keep going. Let's go back to position A. All right, all I know so far is potential energy. But if I take this into consideration, it's at rest. It has a velocity equal to 0. That means it's not moving. If it's not moving, what kind of kinetic energy does it have? If kinetic energy is moving energy, my kinetic energy at position A is 0. If I plug in a value of 0, doesn't matter what the mass is, the kinetic energy is 0. Mechanical energy is the kinetic energy plus the potential energy. That gives us a total of 80 joules of mechanical energy. Now, what we learned from the previous examples of both the skier and the roller coaster, the mechanical energy does not change. So if the mechanical energy at position A is 80 joules, the mechanical energy at position B is 80 joules. The mechanical energy at position C is 80 joules. The mechanical energy at D is 80 joules. At E is 80 joules, and at F is 80 joules. Now, position B. If I have calculated that my potential energy is 40 joules, I know my mechanical energy is 80 joules, therefore my kinetic energy must be 40 joules. At position C, I know my potential energy is only 20 joules, but I have a mechanical energy of 60, so my kinetic energy, of 80, my kinetic energy is 60 joules. All right, look at position D. I have a height of 0. I actually don't have to do the calculation. If my height is 0, my potential energy is also 0. I have no potential to squash you like a bug. That's what potential energy is all about. If it has no height, it has no potential to squash. Potential energy of 0. If my mechanical energy is 80, my kinetic energy is 80 at position D. Now let's go to position E. I have a height of 2 meters. Sounds familiar. Oh, at position B, I also had a height of 2 meters. The ball has the same mass at positions B and E. It has the same height at positions B and E. It has the same potential energy at positions B and E. So I have 40 joules of potential energy at position E. If I have 40 joules of potential, 80 joules of mechanical, that means I have 40 joules of kinetic. Position F, all the way over here, 4 meters height. Sounds familiar? There we go, 4 meters height at position A. So 4 meters and 4 meters, same height, same ball, so it's the same mass. My potential energy at A is the same as my potential energy at F, 80 joules. If that potential energy is 80 and the mechanical is 80, my kinetic is 0. If I start a ball at rest here and let it roll down, and there is no friction, of course, no friction, pretending there's no friction, it gets all the way up to this other point up here and it goes, and for a split second it stops. It's at rest. It's not moving. Just like we do the projectile motions, we throw a ball straight up in the air for just a split second, it stops. And then it comes back down and then goes over and goes all the way back up to the other side and stops. And then it comes down and goes all the way across and back up and stops. And goes back and forth. And it will go back and forth forever if there is no friction. Now, in reality, there's friction. So, the first time this ball goes down, it's not even going to get all the way up to position F. It's going to end up about right there. And then it's going to go down and come all the way back up over here. But it's not going to get all the way to A. It'll get about right there. And it's going to go down and about right there. And then it's going to go down and right there. And it's going to go back and forth and back and forth and back and forth until it stops at position D. That's reality. But in an ideal system, we have no friction, so it would go back and forth forever. Take this worksheet. We are going to glue it into your journal. Okay, the first thing you need to do is you need to cut it in half, right down the middle. Okay, next thing you do, you need to cut the white off the bottom of this side, right below your graphs. Cut off the white extra. And at the top of this one, cut off the extra white as well. Once you have that, you can take it, go to your journal, find the page, take the one that has the graphs. That one's going to go on page 32. Right below your formula, you should have just enough space, so if you didn't take too much space, and glue it in. If it's too long, then just fold up your graphs like that so that it fits. But hopefully it will fit just fine. Okay, go ahead and glue that in right there on page 32. Now, do not turn the page. This is going to go right here on the oops page. Do not turn the page, just put it right there on the oops page. Just as it is, no trimming needed. It fits as is. Let's take that and glue it in on the oops page. Right there. So mechanical energy, page 32. Oops page, it's all right there.